Right, welcome back to another Chess Engine in C video. And last time we were able to implement moving pieces normally, like, the pawns move 2 steps forward on the first move, then only 1 step. And I also implemented a way to have the uh, sides move one after the other, so I cannot move another white piece, I have to move a black one, and then I can move another white one. And we are also displaying the previous move that you made, or I guess the last move that someone made. And yeah, I was thinking to try and refactor the way we generate the moves, because I thought it's kind of inefficient. We are generating right now a list with let's say all the moves, but I was thinking to try and use a different method. So instead of just generating a list of the moves, what if, which I mean it's using dynamic array and it's maybe allocating a lot of memory. I was thinking, what if instead of doing that, we'll try to use something like a 2D array of the same size as the board. I mean, it's a 1D array, but we can imagine it as a 2D array. And we are going to use something like a visited map, where you put a 1 in the square that you can go to with that piece, right? So we would have ones in these places. And maybe we want to also have stuff like, okay, if it's a capture, we use 2, for instance, or something like that. Or maybe if it's a move like this one, the en passant one, maybe we use a different flag like a 4. So basically we can see on that list of moves, which is gonna be always the same size, we can see what kind of move we are actually making. So for instance, let's say I make something like this, then now you can see right now it's still working even with this implementation. But we can have stuff like, okay, for a castle you would have another flag, maybe 8 or something like that. So you would see that, okay, the king can move here, and it's a move of type 8. So when we if we select that move to play it in the apply move function, we would know, okay, so it was a castle move, the king moved here, so we also move the rook from that side. And basically we don't need to keep track of a bunch of stuff in the move structure. We would only use these kind of flags to indicate what kind of move we are making. So I think that's kind of an interesting idea to try, right? So yeah, right now we don't have castling, but that's something that we can try to do. So yeah, that's what I would like to try and achieve today. And obviously the game still works in Wasm, obviously still works, doing the same stuff. But yeah, it's just that it's in browser, so it still works. So we have both native and Wasm builds, which is kind of cool. But yeah, let's try to see what we can do. So for instance, I would say we will not need the move T structure anymore, because we are not going to use like a list of moves. I'm thinking to try and use the flags, and yeah, so and basically we'll just delete stuff like this. Maybe I'll keep the make square one just in case. Obviously we'll need squares. That's because when you select a square, you need the coordinates for that square. But yeah, okay, so let's try to create these flags. So maybe I'll go here and just go with define chess. We'll still keep chess none as the base thing for all of our things, but then I'm gonna do chess move, so it's just a simple move. Then maybe I'm gonna do, but you know what I mean, it's gonna be like binary, right? So you can live with that. Chess takes is gonna be a 2, and the reason why it's gonna be powers of 2 is because a 2, you write a 2 as 0b 0 0 1 0, right? And this one, and then we can actually combine them, so it's a move where you take something, or maybe it's a move where you do n peasant. But yeah, hopefully you get the point. I think that's how it's spelled, n peasant. Yeah, with 2 s's. So this would be a 4 kind of move, then maybe castle is gonna be an 8 kind of move. And what's kind of interesting about this is that so far we only have moves that fit into a char, so that's kind of cool. These moves fit into a single char. Okay, so yeah, these are like the flags. Okay, nice. So the init function for a board is gonna stay the same. We don't change anything. Setting, like getting a piece from here stays the same. Setting a piece stays the same. Applying a move actually is gonna change. So how is apply move going to change? Well, I mean, move t, it's kind of obvious we still need something like that, but I would say square t start, square t end, and the move is gonna be a char. So inside of this char we are going to have the flag, right, for this, the move flag basically. Okay, and what about chess valid moves? This one, obviously it needs the board. It should need, like, it, yeah, it kind of needs the last move though. So your last, or I guess your opponent's last move, because with your opponent's last move you would be able to say if you can make an en passant move, but yeah, that's kind of needed. Okay, obviously your starting position, I'm not sure if I want to have it as a separate structure, move t, or if I'm fine with that, I don't know. But then for this one, what if we have a chessboard t, so the same structure as the board, which is going to give us the moves. All right, and this is a char thingy. But yeah, that's kind of interesting. I mean, last move, what if it would be part of the board? So instead of having here chessboard D, maybe we want to structure chess state or something. And inside of chess state, we can keep more stuff. So why not? Let's try to create our type dev struct chess state t, and inside of chess state t we'll have the chessboard. Okay, I need to move this one here. So I would say we need a chessboard t board. We need a board. We want something like int last move. So this is a flag one if we have a last move basically, and then QWERTY last move start, QWERTY last move end. So basically from where to where we had the last move. And based on that we can even figure out what kind of piece that was, because you can just take it from the board and look at the end position. Okay, and obviously here we might even have stuff like int rook moved, for instance. So if the rook moved, you cannot castle anymore, stuff like that. But for now, let's just keep it simple with last move. So maybe when we initialize this thing, we want to initialize it with chess state t actually. Maybe we want to initialize the state, and when we do get or set or apply move, we want to do stuff like this on the state. Check valid moves on the state itself, so we don't need last move. And start is basically, what valid moves can I get for a piece that's on this square. That's fair enough. And checking if the king is in check. We'll see if we actually need that anymore. Flip player, chess count positions or whatnot. Okay, whatever. So let's try to go inside of chess.c and try to refactor these things. So here we are basically parsing the fan string, and here we need to do something like state board, obviously the reference. What do we want? Oh, we want a state. Because this works on a state, chess square state. Interesting. I mean, see, this is kind of awkward because like apply move, sure, it makes sense to work on a state, and chess valid moves, it also makes sense to check it on the state, right? It also makes sense to do that, but these things, I think maybe it makes more sense to do them on a board, because why would I need that info there? I'm also thinking that, okay, when you initialize a board, maybe you are doing some puzzle and somehow it depends, like maybe the last move was something special, or like the king cannot castle or something. I don't know if the fan notation notes that. I don't know what this stuff is, honestly. So maybe we want to initialize the full state. Maybe this notation here's, I should check what it means, but maybe it tells us something important, right? But maybe these two functions, chess square get and set, maybe they should work on the board, right? I think that they should work on a board, but initialize, I think it's fine to work on the state, because maybe we want to initialize something more complex. But let's keep square get and set to work on the board, and init fan and all of this stuff to work on the state for now. We'll see if we need to change that. So here we can do board, right? So that's what I think this initialize should look like. And maybe we want to initialize something else on the state depending on the fan string, but we'll see. Okay, get and set stay the same because we didn't change anything. But now apply move becomes a bit more interesting. So apply move. Right. Let's comment out this stuff and let's imagine what would happen with the moves. So I guess we could just do something like the edge case directly. Like we check if it's an n peasant, and if it's an n peasant, we do something with it. So maybe something like if move and chess and peasant how do I do that is different than 0. So if we have an n peasant, we're gonna do something. Okay. If it's just a move, we're gonna do something. So if it's a takes, chess takes, we're gonna do something, right? Something like this. If we have chess move, if we have a chess move, not 0, we are gonna do something different, and so on. So if it's a takes, we want to just get rid of this thing. If it's chess move, we are gonna do this part, and for n peasant we are gonna see. So basically here we want to do reference state board. We are gonna set to none the end position, right? We are gonna set to none the end position, and I think we want here, what did I do? We want chessboard, obviously the start position, like this for a move. That's good. And now for the n peasant one, we know where the pawn goes, right? So I'm going to try and compute what do we need to take. So we might, what would be the position to take at, or maybe what's the direction? So we know we're gonna move forward. So let's say int diff, let's call it diff, is gonna be end dot rank minus start dot rank. So we move on the ranks and we get the difference. Right. So well, I mean, I'm stupid. The position where we need to take is gonna be square t. Let's call it take. Why not? It's gonna be square t, and the rank is start.rank, and the file is end.file. That's the only thing we need to do. And we are gonna set to none the piece from the take position. So that's how the end peasant move works. We are taking the piece right next to us. Okay. Okay. I guess. And you know, when it's gonna be castle, we are gonna look into that as well. But for now, maybe I'm gonna do something like if move and chess castle. Can I use DS panic? Oh, I don't have. I should have. Not implemented yet. Okay, so I do have access to DS panic. Perfect. So it's just gonna panic that we didn't implement it yet. Okay. Alright, so if we go back to chess.h, we did apply move. I think that's all we need to do for apply move, honestly. Because we'll get the start position, the end position, and the type of move, right? And we just try to apply that move. Okay. So the next step is trying to get the valid moves, which is going to be more interesting. Now it's, you know, it's a bunch of errors. That's fine. Chess valid moves. Okay, whatever. These ones we can comment them out just to not have, you know, just to not lose focus. And let's take a look here. So we take a piece. What's annoying is that because we have a bunch of compiler errors, let's just comment all of this out. We don't see all of them because whatever. Wait, what? Oh, it's the nested comments, man. Okay. Nice. So let's try to fix this one. So we take the piece, we see what color it has, right? And we need to get all the valid moves for this piece. So it's gonna be state, start, and moves. So this is what we need to implement. Then that's kind of interesting. We need to figure out which moves are not good. I don't think we can do that beforehand. Like, I don't see how we can do that beforehand, honestly. So I still think we need to do this one later. But the idea is the same. We need to do all the valid moves and then remove the moves that would cause you to lose the king instantly, right? So that's my idea. So here for this one, I'm just gonna do ds mem copy. We would need mem set, maybe mem set is better. We should mem set. So mem set is the destination, value, and size. So it's 0 and chess width times chess height, size of char, because that's what we are using. And yes, mem copy. Let's just implement the mem set. It should be similar. ds mem set to set memory to run to a value or whatever. So if it's defined, it's fine. If we don't have stdlib, then we just use memset, and otherwise, I mean, it's destination, character, and size, right? Otherwise we go until sz, and we say something like is equal to C. I think that's all. Maybe this needs to be done with int because C is an integer, but I don't know. I'll just keep it char. Okay, whatever. So we do memset with the value of 0, right? And then we try to get the piece. So state board at the start square. Okay. Then here we need to pass in state and the start square. Okay. Maybe calling it square is better, I guess. But so we basically need to rename all of these with state and start. Okay. Obviously some of these don't. Oh, I was highlighting exactly the one that needs the state. The pawn moves and the king moves. The knight, bishop, rook and queen, they don't care about the state. I think that's all. So let's try to get these ones fixed. So let's ignore the pawn one first. I know it's pretty funny, but let's ignore the pawn one. So for the queen, chess state T, and then we have the start square. So for the queen, it's pretty simple. State arrow. We just need to add these to the board. Okay, make move. It's interesting. So okay, yeah, we just changed how this one behaves, but that's kind of it, honestly. So it's just chessboard. So we basically have to do something like moves. Chess square set. That's pretty funny. I mean, chess square set into moves, and we have to set, wait, the square, which I guess it's called target, and the piece is gonna be chess move, right? It's gonna be chess move. That's pretty cool. And in this one, because it's a capture, we have to do or chess takes. Maybe I'm just gonna call it capture. Just to have a better name. So if it's bounded, we do that. Maybe I can do something like char move is going to be equal to chess none, and then move is going to be chess move, and move is going to be chess move or chess capture, and then we set the move here. So it's pretty funny how we actually use this set function to actually set a char in an array instead. So yeah, hopefully it makes sense how we change this thing. Instead of using an array, we are just using a visited list, basically. I think that's a bit better. So here we need to use moves again. Now this one is a bit interesting. So char move is gonna be chess none. If we don't have any piece, then move is gonna be chess move. If it's a different color, now this one is interesting because it needs break. It needs break. Yeah, I mean, because it needs a break, then let's just do chess move here, and it is what it is. And here is gonna be a move, but it's also chess capture. And I want to keep move and capture separate, or I guess keep them both, because honestly, I don't know. But it's like when you do a capture, you just remove the enemy piece, and when you do a move, you remove your piece and then you add it on the target square. So it's like this is also capture and peasant, but it's different. So I don't know, I just want to have them separate. For me it makes sense. I don't know if it's actually helpful, but it does make sense. So okay, let's replace this thing exactly the same, because it's the same thing. As I said, the rook, bishop, and the queen move exactly the same, but the only difference is the rank diffs. So the bishop has the first 4, the rook has the last 4, and the queen has all 8 of the diffs, or I guess directions, but you get the idea. Okay, so let's replace this stuff as well, and we should generate the thingies. Okay, let's do the king now. So it has the moves, and in here it's gonna be kind of similar. We set this, and here we set chess capture. I mean, honestly, there's no difference in using capture and move. It is doing the same thing. So if I delete this if, nothing would change, but I still think it's a nice idea to have them separate. I don't know though. Maybe maybe move can be combined with capture, but yeah, I guess maybe I will combine move and capture, combine them together and save some lines of code, I guess, but we'll see. Okay, so this needs to be chess state t state, and here we need to do state arrow. I guess I forgot about that. Chess state t state chess state t state state board. State board, and I think that should be all. So now we should be able to do the varied moves for a pawn. Okay, perfect. So varied moves for a pawn. we need state, start, and piece color. So this would turn into chess state t state. Let me just rename this one to start. Last move is not important. And this one is a chess board t moves. Perfect. So here we take that. This is a forward move. So basically we just set the move to move. Really straightforward. I guess forward is the square where we want to move. Then here we have forward left, which is a chess move and chess capture. Again, maybe I want to change. I guess I'm just gonna do that after we solve all the errors, because I don't want to, you know. So this would be right state board. This would be forward times 2, and it's only a chess move. State board and state board. Okay, I don't know. And now this one is kind of interesting. Has moved is has moved should be inside of the state. If we have a last move, then state board, state last move end. So that's the last move. We try to get the piece that moved somewhere. If it's a pawn, then state last move end minus state last move start is equal to 2. State last move file whatever, and state last move. So these are just the checks that we were doing last time, but I'm taking the last move from the state, which, yeah. So basically we want to move the pawn at forward amp, right? Yes, forward amp. So I'm just gonna do same thing like here, and it's gonna be forward amp, forward amp, chess move and chess and peasant. Okay. So I was like, oh, but what if you can do something, I don't know if it's, but it's not possible to have, let's say I move this one here, this one here, this one here, this one here, then you'd have something like this and it capture this one as well, you know, like, but it cannot jump over the knight. Okay, it's fine. So I think this should be all when it comes to this one. Chess valid moves all. Okay. So let's cut out this one with in check. We'll do it later. Let's do count positions. So here we'll have chess state t state. I don't remember what current is. It's like the side, current side, depth, and maybe allocator. So we are doing that. Chess square get state board. Then we need the valid moves. So for the valid moves, now you can see where we no longer need to allocate memory because chess board T is just like a statically known at compile time, right? So we don't need this part. We pass in the state, the square, which is like the start square, and we write into moves. Maybe I want to call this one start. Right? So here we need to iterate through all the moves that maybe we made, and that's just chess height times chess width. And basically, if shit. Kind of want to do it like this. File I is equal to 0. File I is less than chess width. File I plus plus. And then do the same but for tank. Rank I. Chess height. And I'm just doing underscore I just to have some different name than these ones. Okay, so here I'm gonna do the end square, which is gonna be file I rank I, and we are gonna take a look at the move. So chess square get, and we pass in moves and end, basically the end position where we want to move. And if move is not equal to chess none, then that's like a valid move. So let's see what we can do about that. Maybe we can do something like creating a clone of the state. So clone state and size of chess state T. And I think this should be fine to mem copy it like that because there's no pointers, right? So it's only values in here. So hopefully just mem copying it is gonna be fine. And then we want to apply move. We want to apply move like this. We want to apply a move on the clone state, starting with start, ending with end, and the move is a move, right? And then we are going to count the moves on the state. We don't need a move. We flip the player, we decrease the depth, and allocator is not needed. That's true. So in chess.h, we no longer need the allocator, which is perfect, right? So it's doing exactly the same stuff. We are just instead of using a list, we are using like a 1D array. Fine, it's not 2D array, but you can think of it as a 2D array. It's like the visited list. think it should still work. Maybe just here I'm a bit concerned, but it makes sense. Memcopy should just copy the structure from one structure to the other. We don't have pointers, so a shallow copy should work, which, I mean, it's memcopy, right? It's shallow copy. I think that's fine. So let's see the last function that I was looking into. Chess is in check. This one is for the varied moves. Maybe I don't care about it right now that much. Let's try to run make. 269. That's gonna be needed. So if I just run this main, we should shit. Let's go to game.c because here we didn't update game.c, so I don't know why it compiles. Make clean, make. Yeah, it's weird. Why did it compile? Anyway, so we have the allocator, we have textures, we have a board, but what I would say here is, what if we have a chess state t, state is equal to 0, and we no longer have the board, we no longer have list of moves, we should have a chessboard t for the moves and not last move and current player. Okay, so let's see what this is gonna bring us. So we have the texture stuff. Maybe we can even move this stuff into somewhere else, I don't know. Pixel to square, square to pixel, these are fine. Allow texture, chess print board should take as an argument the state, chess state, the pointer state. That's fine. So here it's state. If we have a last move, then we do state last move start file, state last move start rank, and we draw the square with a light or dark or whatever. Then here, if we have last move defined, we draw the end point. We draw the endpoint, obviously. Then here we need to do it with board. And then we need to draw the moves. So to draw the moves, I'm going to do something like this. File rank, right? We need to get, and I would say here we even need chessboard the pointer moves. What's kind of annoying here is that those are global variables, so maybe I just want to global variable it. Maybe I want to, yeah, let's just global variable it. So this would be like that, because we are using textures anyways, like a global variable, so I don't mind it. Like this should be part of main anyway, but it's too long and I'm like, just gonna do it like this. Okay, perfect. So here we are reading from moves, right? Oops, we're reading from moves, and if move is not chess none, we should draw something, and I think that is something like this. We need to draw a circle for the move. So let me just do it like that. And this should be a square T. Let's call it end because it's the end positions. It's the end position. Right? For instance, here it's just a square. Maybe I should square T square to have like better. Okay, whatever. So it's gonna be end. We square to P exit and we draw a circle. Perfect. Like this function is just drawing that stuff. Okay, and validate selected move. That's interesting. Validate selected move. So how can we do that? Well, we need to have something like start square T end, and basically, so we'll have obviously a square for start, a square for the end position, and we want the end position to be in the list. So we just need to do this char move, and we are just going to return, move is not equal to chess none. So I think that's all we need to do. It's just a flag. So we don't even need start. Is not equal to chess none. So that's validate. Validate is, damn, it's pretty simple validate. So we might not even need that function, honestly. Perfect. Okay. So here we do some allocator. Here we were doing something stupid, which we don't need anymore. Maybe we just want to ds mem set moves with a value of 0, and it's like size of chessboard T. That should work. Here we need to pass the state, and we just initialize it. Nice. Okay, perfect. Then here we need to print the board after we draw like clear background. Here we need state board, chess valid moves is gonna be state and write into moves. Nice. Okay, let's think about it. So square is the hover position basically. So here I need to say square. I don't know why I need that for. Let's remove that. Let's remove that. Let's remove that. We flip the player. So we need to apply the move. Chess apply move, which needs the state, needs the start position, which is, I think it's selected square, honestly. The end position should be square. And the move is, actually we need to keep track of move, and the move is just this thingy, and this should return void. Perfect. And we need to save the last move. Should apply move do that? should apply move do that? I think yes. So if move is not equal to chess none, I want state dot last move to be equal to 1, state last move start to be equal to start, and state last move end to be equal to end. I think I want to do that here. So this should actually just apply the move. We still have some errors. Clean. That's inside of main. Interesting. Chess state the state. Initial position, we don't need an allocator, and that should actually be it, right? Interesting. So this main, let's see if it still works. Kind of. We don't clean up that. Fair enough. So it yeah, that's guess that's kind of true. So if we go to game, maybe I made some mistake here. So if you press left mouse button, right, if chess square get but square is the current player, then we set selected to true. Selected square is equal to square, and we generate the valid moves for that piece. Perfect, it makes sense. Otherwise, if the piece is not yours, I guess that's what it means here. If the piece is not yours or it's an empty square, that also works, right? We get the move from the list. If it's chess none, we don't do anything. But if it's not chess none, so if we have a move, we call apply move, and we set the next player. So that means that if I do something like this, I can move again. Okay, yeah. So we still have so it's the opposite player and the moves are already there, so we should reset moves, I guess. That's the problem. I mean, already knew that, but I was thinking that maybe it's something else. But obviously we have to reset the moves. Let's see if this helps actually. So if I click here, it's nice. So it's kind of working. Interesting. But now you can see that we can still make moves even though the king dies. So we need to put back that logic. But pretty quite happy that this idea actually worked. I mean, I was expecting it to work, but it feels much, honestly, it feels much better than the previous way of doing it with this kind of flags. So let's try to get this stuff to work. Okay, so my idea previously was to have this kind of chess is in check function, which is a function that tells you if the king is in check or not. Chess state t. I assume we won't need an allocator, so I'm just gonna remove it. And let's see. So we take the enemy point of view, we iterate the board, we need to take a piece. If the piece is an enemy piece, I was generating the moves, but to generate the moves, now we just need chessboard t board is equal to 0, and oh, I'm stupid, it's moves. Okay, and here it's state. So we just generate all the valid moves for this square, and then here we need to iterate similarly to this. We need to iterate our visited mapping. So file I, because I don't want to, you know, make this shit itself, it needs to be different index names. Okay, so I was getting the move. I can just do get. So where I was using that, because I just wanted to copy paste it. I think it was inside of game. Let's see. The fuck, rank I. I was doing it here. Here. Yeah. So I was doing like end position of this square, right? I was getting the move, and if, let's see, I was getting the move, but the move is not that important. I guess it is, because I want to see if move is not chess none. So if we can reach there, right? If we can reach to that move, we need to say something like char piece is chess square get at state board and end, and then if that piece is the king, we return 1, just like this. And yeah, we don't need to do anything afterwards. I mean, it's kind of like it has more for loops, but I would say, yeah, I'm not sure, maybe it's gonna be slower actually, but it's less overhead. Even though it's more iterations, it's like constant time if you think about it, because it's chess width times chess height, which is 8 times 8. And in the other approach, we were using malloc and allocating a lot of stuff, so maybe it's better like this because this doesn't allocate memory. I don't know, we'll see. So here we need these for loops for the moves. Then I need to get the move. I need to make a fucking clone, what? So I need, okay, I need the end square, I guess. I think I need the n square. Here maybe it's if move is not chess none. So if we have a move there, we need to apply that move on a clone. So I need to create a state clone. Chess state t clone is 0, dsmem copy into clone from state, size of chess state t, we mem copy it. Wait, what? Oh, we mem copy that. Then we need to apply the move. So, oops, apply move. Now apply move has changed. Oops. So apply move goes on the clone. It starts at start, it ends at end, and it's move. That's the type of move. Okay, and then we need to check if we are in check. And if we are in check, then I'm just setting the basically chess square set onto moves. I set the end to chess none, right? Because there is that move would make you lose. Okay. So now if I do something like this, then maybe this, then let's say this, and we check the king, this can move only one square, this can only move here, the queen there, the horse here. So it's like only certain pieces can move, right? That's pretty cool. So yeah, I guess that was my idea here with changing this approach into using a state and that other thingy, which I think it's pretty decent, right? I don't really see an issue. So the castling would be the next big one that we want to implement. Yeah, I mean, it could be less code. I don't know if it can be, but let's double check now. Count positions at depth 1, it's 20. Shit, it's still slow. It's still slow, but I don't know if it's slower. I should have timed it just to see. Chess valid moves knight. Yeah, maybe that would have been a good idea to time it and make a comparison. Huh. But I would say that I think that this approach uses less memory. So at least we have that. Okay, chess is in check. I think it's slower. $119 and $324. So for this one, it's okay. We get the right answer again. But it somehow feels maybe slower. That kind of sucks. But I'm gonna say that it feels much simpler. Like the code feels much simpler to work with. like this, by having these kinds of flags. So let me just commit this factor, use flags for generating moves. Can we maybe git checkout head 1? So this was the before. So let's make clean make, and let's maybe time this one. So on the old one it's doing 65 seconds. Let's make clean make, and let's try to time it on the new one as well. Like the only difference I saw instantly was the amount of memory. The old one like goes on my machine to have like 30 or 40%. So it's clearly that we have some memory leaks probably, but it's also interesting to see like the time, I guess, which might be more important. But yeah, we'll see, because honestly I like this one more, even if it's slower. It feels a bit more intuitive to work with, so yeah. I mean, this one is interesting. I could just do size of chessboard D. Still work. So, whoa, it's actually faster. So, then I mean, this is better. I mean, it's faster by more than 10 seconds. So, and that's like what? It's like almost 15% improvement. So, clearly better. Right? So, yeah, I would say that this was then kind of a success. Nice. Okay, so maybe now that we finished this part, we can try to take a look into how we can do the castling. We can try to make it as basic as possible first, and then try to solve from the errors. Like, what if first we just check if you can actually castle? So without checking any state or any like rules, and we'll just say, okay, if there is empty space between the king and the rook and they are on their home squares, then you can castle. And then we'll start to add things like, okay, but has the king moved? Is the king in check? Is the like you know, those positions where the king goes, are they in check or something? So stuff like that. So let's do here maybe castle short. And what do we need for that to work? Okay. Int is king home. So is the king on the home square? I mean, that's like for every kind of castling. So how can we check that the king is on the home square? It's kind of annoying that it depends on the piece color. So what I'm gonna do is king, or maybe home rank, and that's gonna be piece color is equal to color, or I don't know, chess white. If that's true, then the home rank is 0, otherwise it's 7. Right? So is king home? It's A, B, C, D, E. So it's 5 and home rank. So int king home king square. let's make square, and it gets the rank and the file. So it's home rank and the file is 5. And that's the king square. Oh, square t. Is the king home? What do I need to do here? Chess square get, and we're going to say state board. We need, what else do we need? The square. We need the square. King square. So is king home? So this gives us a character. So we need to do something like end chess king. Shit. How can we figure out? Maybe we can say something like is equal to chess king or piece color, right? So it's like, okay, if we have the right king on the right square, then int is rook short home, maybe square t rook short square is make square on the home rank, and it's 7. Oh, here it's 4 because it's 0. We start with 0, but you get the point. Okay, let's check if we have chess rook on the rook short square. So if we have these two pieces and no pieces in between, obviously, so int is short 3, we should do something like chess square get a board, and let's do make square. We are interested in 5 and 6 to be empty, so home rank 5 is equal to chess none, and the other square is at 6 is equal to chess none. So if these two are none, then short is free. So then that means that, so if is short free and is, oops, and king home and is rook short home. So if all of these are true, then I want to be able to move these guys. So what I'm gonna do is chess square set inside of moves, target, and chess move. So it's gonna be, what's the target square? It's gonna be make square home rank, and I think it's 6, right? 6 chess move and chess castle. So this should give us short castle. this should give us short castle. So if I move this guy, this guy, this guy, we should, I mean, not implemented yet, but why did it go to not implemented yet? It's gonna try to apply the move. Okay, perfect. So doesn't matter. So let's see. If we are trying to castle, right, it means that we want to move the rook from its share position. Shit. I mean, it's castle short and castle long. It's two different types of castle. Right, like it makes sense. Castle short. Okay, so if it's castle short, square T rook is gonna be make square. So first of all, it wants the rank, so it's start.rank, obviously, and the file is 7. And that's the like we are gonna trust that castle short is possible. Wait a second. Yeah, no, it's fine. Okay, so then I want to set square set state board at rook with chess none. All right, and I want to set position 5 with chess rook. And what's the color? Maybe no. I'm gonna do it another way. I'm gonna do sharp piece is equal to chess square get at the rook position. We take the piece and then we just set it here. So it's just swapping them. Okay. So that should do short castle. So if we go again, do some random moves, we got fucking castling. And it works for the black king. Man, it's so easy. Like it became much easier with this kind of approach, honestly. Like it's so much better than having to add all of those weird fill in the structure. I think it's much better like this. Obviously, we still have to do some checks here. It's not done yet, but you know that's kind of what we are after. So let's do the long one as well. So square T rook long square is make square home rank and 0. Okay, is rook long home. We are gonna take a look at the long square. It's there. Okay, and then is short free, which is actually is long free. Okay, but this one needs 1, 2, and I think 3. I think it's only like the horse like the knight, the bishop, and the queen in the way. Okay, and in case of that, if long is free, king is home, and the rook is home, then we move the king to, I think it's to 3. No, 2. It's 0 and 1 is gonna be empty, and we are gonna, castle long. Nice. So let's go here. Let's copy paste this one. So if we want to castle long, then the rook starts at 0. The rook is going to teleport to square 3, and that's that. So let's double check. So if we now do something like this, random moves. Let's pull the horse out. I think that's how it looks like, right? Let's see if it works to castle opposite sides. Oh, I want to see if I click. Nice, so now you can castle both ways, right? It's pretty cool. But what's gonna be funny is if I do something like this, I can then castle long. That's pretty cool, not gonna lie. Right, so you can literally just move the rook there and then bring the king over. Oops, I brought it to over. And castle again, which is kind of funny. So that's why we need an extra field in the state, which is gonna be something like has the king moved or the rooks have moved or something like that. Okay, and probably also in here in this one we need to check that the king is not in check and these squares are not in check, or I mean, which squares do matter? I guess an important one is, so if I run the game again, if we get to this kind of position like here, if this square is in check you cannot go, and obviously this one is in check you cannot go, but if the rook is in check I don't think it matters. So we'll need to check if this one is in check, this one is done automatically, and if the king is already in check. So if these two right next to the king are in check, we'll have to check that. Okay, maybe we'll want a function something like chess controls. So if side controls a certain square, so this should tell us if a certain side controls that square. I can just say current, and then we can just check if the enemy controls these 3 squares, right? Then you cannot castle, basically. Right. So if these three squares are controlled, you cannot castle. And if the king has moved. So maybe here is gonna be king moved, and it's gonna be chess white if white moved, and chess black, or right, it's gonna be these two flags if black moved. Then we can have a short rook moved, obviously the same thing, and long rook moved. So these are gonna be needed for castling. Okay, so if we go back, let's add these things. So move something, move queen, move the king. So I guess can short, and it's gonna be state king moved and chess, oh no, and piece color. So if this thing is equal to 0, right, and state short rook moved and piece color is equal to 0, that's when it can short. Then can long is state king moved and piece color is equal to 0, and state long rook and okay. And then we have the apply move function. Where is apply move? In the apply move one, we should check the start piece. Let's take a look. So char piece is equal to chess square get state board at start, right? If piece and chess king is not 0, char piece color. I know I did this one before. Maybe not. I thought oh yeah. Oh, I can also do that. Piece type. So if piece type is equal to chess king, and what did I want to do with piece color? Nothing. I wanted to do something like state arrow king moved or equals to piece color. So we just set the king moved to true, basically. Okay. And do we need anything else? Do we need anything else? Obviously the rook. So here if piece type is equal to chess rook, then I'm interested in the start position. So if start dot file is 0, shit, not really. I mean, it's kind of true. Start dot file is equal to 0, but we need the state long rook moved to be 0 as well, or like end piece color to be 0. So why do we need that? Because you can slide the short rook on the 0 rank or like on the first file, and then when you move it again it's gonna think that it's the long rook, but it's actually not, right? Yeah, so it's basically if the start file is 0 and the long rook, shit, what? No, that's not true. I mean, if the start file is 0, so if the start file is 0, let's say, and the rook is on the first rank, then it's not possible. It's moved, so it has to be moved already to be there. Okay, so maybe it makes sense. So let me just copy paste this small thing. Where is the king move? The home rank. I need the home rank. So we take the home rank. So if the start file is 0 and the start rank is home rank, then state arrow long rook moved becomes true. Because the only way you can be on the home square of the long rook is if you are the long rook, or the long rook moved, which is true already, and yeah, so you get the point. And the other option is if you are the short rook moved. So can long, what can long, so basically now if I do some random moves, I can short castle, but if I move the king, I can no longer short castle, but this guy can. Oh, I have to. Oh, this one cannot short castle either. What? Here it's an end. King moved and piece color. What the fuck? We or this bitch with piece color. Pretty interesting, not gonna lie. But why? So king moved and piece color. Percentage D. King moved. Piece. So let's make some random moves. No, that guy can castle. The fuck? Wait, did I forget to compile? Like what? Maybe I forgot to compile. Yeah, maybe I forgot to compile. Okay. So if we try to castle this bitch short, or I guess long, it can go long, but if I do something like this, it can no longer go long. Can it go short though? Nope. So that's good. Anyway, like the test case is gonna be this number right here, which is really big. I think it's gonna take a few hours, honestly. So yeah, maybe we can find a better starting position with the number of possible positions for it. Maybe we can do that. Hopefully that's better, right? So that's my idea. Maybe we can find a better test case. So that's the first case. And the other case is checking, like inside of this chess.h, if the enemy controls your squares for castling. So we need to implement this one, which is gonna be similar to check. So what do we want to do? Probably some for loops. We might want, so we want to see if this player can attack this square. That's what I want to see. So I'm gonna take the piece that's there. If we have a piece, right? So if we have a piece there, if we have a piece, then we need to generate all the possible moves. Now I don't think it doesn't matter if it's oh shit. Yeah, like it doesn't matter if it's like all moves. It doesn't matter if it's blocked. So I think, yeah, I think it's like that. I think it's gonna be like that. So we need then these two for loops. We need to get the end position, and if we can reach and shit, what? No, I already have that. So we get a move at square if that move is not none, then we just return true. Otherwise we return 0. So it's basically, can the enemy reach this square? If yes, then that's that. So we can actually re-implement this function based on that. So we have the enemy, and then we can search for the king. I guess square t king square found. I mean, found should be true. So come on, that's fucking stupid. But what we should search for is a piece. And here it's something like if piece is equal to king, chess king, or current. I think we need to print current, what? Then king square is equal to square, found is 1, break. Or I guess, and found is 0, right? I can do that. Found is 0. So at the end, we can just say chess controls state king square current. Yes, expect. No. If found is equal to 0, playing without a king, SMH. Okay, so then we do chess controls. Oh, but we need enemy. So enemy is actually here. $378. What the fuck? I overwrite square. We'll call it target. We'll call that square t thingy target. Okay, so if I just run main, it should still work. So I cannot move this one, I can move this one. Let's say I do that, let's say I do this, let's say the enemy does this, king is in check. It shouldn't be able to castle. Now it should obviously be able to castle, but alright, it doesn't matter that it was in check. So perfect. So how can we use chess controls now? How can we use chess controls? So when we are doing the move king, int, no, is in check, should be chess controls state target current, state king square, and the color piece, no, flip chessy player, scheiße, piece color. So is in check, is short check should be something like, so is short free and stuff, is short free. The square that I'm interested in is the fifth square. That's when short is in check, and when long is in check is it's the third one. So basically here I need to add and not is in check and not is short check, and here and not is in check and not is long check. So if those two are controlled by the enemy, you cannot castle. That's, I think that's the idea. Fuck. Wait, where did it segfault? Maybe it segfaulted here. Or did it segfault there? Let's see. Hee, so many hee-hees. King piece of shit. But why did it hee? Because it's chess valid moves king. The fuck? Why did it get the king? One, two, and three. But it's more interesting, how does it segfault? He won. Holy fuck, that's insane. Chess controls. It calls to itself recursively? Because chess controls gets all the moves from the enemy, then chess valid moves gets the moves of the king, and so on. I think it gets into some kind of recursive loop. I'm not sure how we can fix that, honestly. Chess controls. Okay, maybe we want to move these ones from here to somewhere else. So I guess we could do that. We can move them to when we apply the move. Or into what? No, into the delete moves, basically. Okay, let's move these things into the delete moves. So we'll go check valid moves, right? Whatever chess apply move, chess is in check. So if the move is not none, it could be the state. If move and chess castle short. A second. So here I'm gonna do if move and chess castle short is not 0. Let's say that king square. Maybe char piece type is equal to piece and piece flag. So here maybe I can do just if piece type is equal to chess king. So only if you are the king we do this extra check. We take the home rank, is in check, is short check, is short check should happen only here, and here we have the chess castle long. Oops. Or maybe I can just do that. So if it's a castle short, then I just need to make it okay. And is in check or is short check, then it's GG. You shouldn't be allowed to do the castle. And is in check or is long check, you shouldn't be allowed to do the long castle. So let's see. So this still works as expected. Let's just make some random moves. So this should still work. If I come here, it's no longer working because the king would be in check. That's first of all. Okay, let's blow that. So now if I make a random move, I should be able to go there. But if I come with the queen here, I shouldn't be allowed to do the short castle unless I just block it. I can do it. Okay, and let's see on the long side. So I come here, the king is not allowed to do the short castle. Nice. If I come here, I cannot do the long castle. If I go here, I am allowed to do the long castle. That's nice. Let's do, oh, this knight cannot move. Let's take there. I cannot do the long castle. Now I can do it. So yeah, and I think that's how it's supposed to work. So I think we have all the moves. And obviously, as I said, making like 5 steps, it's already taking 1 minute. So I don't think going for 6 steps. Wait, what? Oh, 6 steps takes like 1 minute. So I think going for something like all the 7 steps to check castling would take way too long. I might just leave it run in the background while I do something else just to see if we get the right number, and I'll let you know next time. I mean, you'll see probably, but I'll make sure that next time this thing will be passing, basically. Like we'll get to, I'll try to find a position. Maybe I can find, some kind of position which is not the starting one, that we can validate that all the moves that we are making right now are working. So yeah, basically now I can say here, feature, implement, OO and O. I think that's how they're called, but I'm too lazy to write the actual names. But yeah, like right now it takes 1 minute to do a depth of 6 and simulate 6 steps ahead, like all the possible moves. So it takes quite long. So yeah, I'm curious to see how implementing an actual engine would work, because I think that we have all the possible moves. I don't think we're missing anything, so that's pretty nice. Almost 500 lines of code for chess.c. Game is just the drawing. It's not that big. So yeah, let's wait for this one to finish. Just want to see another time this the browser version, basically. And also chess engine C, if you want to play around with this one when it's gonna be done, obviously. Right now it's just playing with yourself. You can actually go on the, all these things are gonna be linked in the description, so like the GitHub repo, and you can actually go on this page and play with the game if you want. So yeah, that's kind of cool. It actually took longer this time. Maybe those checks for the king moves made it take a lot longer, which is quite interesting. Fascinating. Okay, interesting. So it takes more than double now in time because of this. Maybe we can improve it by moving it somewhere else, but yeah, for now it's fine. So yeah, and if I npm run build, we should compile this entire thing. Oh, something wrong? No. So something red, but should all be fine. So if I refresh this page, wait, what? Memset is not a function. What the fuck? Wait, where do I use memset without excuse me, what? If not defined, ds-lib. Let me just copy paste this line. Maybe I need to make clean first. Interesting, but it's never using this memset. It should use this one. The fuck is it doing? Hmm? Like obviously if I'm using really weird. Webpack. So I'm compiling all of these, game, chess, and ds.c, and I'm setting no stdlib. Oh, what the fuck? Are you fucking annoying? I wonder why. So is it happening here? Nope. Maybe it's happening here somehow. No. Excuse me, what? Let me just comment it out everywhere. What the fuck? Wait, what? How is it still complaining about memset? It's not even in the codebase anymore. Oh, what the fuck? But it's not even being used. Bruh, what? Yeah, but where is it finding memset? What the fuck? I don't get it. Because this is not good. Why is it okay, let me just home engine C. The fuck? Import object field memset is not. Yeah, I really don't know what to say about this one. Why does it want memset? It's like not even calling it. Yeah, I really don't know. Why does it want memset? I'm not even using memset. Hmm. But yeah, I mean, you can see that I can still play it from the browser. Yeah, it's pretty weird. Like I should maybe look into what changes I made since last time. Like yeah, sure, we added this DS memset thingy. Alright, but it's being defined as memset only when DS noSTDlib is defined. So that should be fine. What the fuck? Also log what? Can I maybe see that being executed? What? Do I get some arguments? Like I should get number and size of number, right? So this is the destination. So I'm curious, what, oops, not to make, but run build 88. So 88. You know what 88 looks like? And I'm like, I thought about this. It looks like the size of this structure. So this size of is 8 times x 64, 68, 68, 72, 76, 80, and is this 88? I'm stupid. It's 64, 68. Each of these is 8, so it's 68 plus 16, and then plus 4 more. So yeah, I think it is 88. So is it the state? Chessboard, chessboard, chessboard. Is it doing a memset here with chess state T? So it has to be something to do with state, but I don't know what. I really don't know. Maybe we have to implement it. So we get a memory. No, let's let Copilot resolve it. So it should be just setting the character. But it's kind of weird that it wants that. Let me go to main. Yeah. Can I just maybe print f percentage zu size of the chess state t thing? Is it? I think it's 88. Yeah, it is 88. So somehow, because it sets it to 0 or something, it does a mem set on it. That's kind of weird. But it does it when I click on things. So it does it twice. when it generates the moves, it looks like it does it twice. Chess where it moves all, but here when I do a mem set, why is this mem set not? Am I fucking stupid, bro? If not defined, let me just do mem set 1. Let's see if npm run build. No, it's not there. What? Here when I do another okay, let's do string ds log info here. It's like pretty weird, not gonna lie. Whoa, but it's not even printing that. What? So it's not doing there something. Yeah, I mean, I don't know. Honestly, I don't even think it matters that much, so yeah. Yeah, I mean, I guess then that's all for today. You know, we are able to still have this working in the browser. I don't know why it's doing that, but kind of weird. And we basically have all the moves implemented. So castling, doing stuff like and peasant. So yeah, we basically have all the moves done. So don't forget to maybe check the game for yourself if you want to see that in the description, and we'll see in the next one. So see you.